Today I'm going to be taking a look at subtracting these rational expressions 4 over x squared minus 2x minus 3 minus 2 over x plus 1. So first we want to make sure we identify the operation that's happening here, and this is a subtraction problem. The directions give us subtraction. Usually it might just say like solve or something like that, but here it says subtract. So we know we have a subtraction problem, and plus we see this subtraction sign. So then we have to go and identify, well, how do I do this? How do I go about subtracting? What rules do we need? For addition and subtraction, what we need is an LCD. The denominators have to be the same. Just like if you were given the fractions 1/2 plus 1/3, you would know I have to make those denominators the same. Same thing applies to rational expressions. So just don't let rational expressions throw you off, like, oh, it's this whole completely different process. It's the same thing, it's just adding fractions together or subtracting fractions. Even when you're multiplying or dividing rational expressions, same rules apply if you're multiplying or dividing just fractions. So we want to find an LCD. Kind of difficult to find an LCD immediately with this x squared minus 2x minus 3 here. So we want to factor that. What we're looking for is two numbers that multiply to -3 and add up to -2. So you just got to play around with combinations of numbers. I think -3 times 1 might work. Let's see. -3 times 1 is -3. -3 plus 1 is -2. Checks out. So we're going to rewrite this as 4 over x minus 3 times x plus 1. Because again, -3 times 1 is -3. -3 plus 1 is -2. And then minus 2 over an x plus 1 we don't have to touch. It's fine as it is. All right, cool. So now talking about the LCD, we notice that they both have x plus 1. So my least common denominator is going to have an x plus 1 factor. And then this one has the x minus 3. So we know our LCD has to have an x minus 3 because the denominators have to be the same. So if one fraction or one denominator has a certain term, they all need that certain term. So I need my denominators to look like this, x plus 1 times x minus 3. On the first fraction, I already have x minus 3, x plus 1. So that's fine. I don't have to touch that one. Where on the second fraction, this is x plus 1. I need to multiply this by x minus 3. Because now they're the same. Look, x minus 3, x plus 1, x plus 1, x minus 3, same thing. Whatever I do to the bottom of a fraction, I have to do to the top. So we're going to multiply the top by x minus 3. And you can slow down a little bit and really write this out a little bit more. But, so I'm gonna write down the next line. Just, why not? If you don't want to see this, and you can fast forward through it a little bit. But I'm gonna write this down as 4 minus 2 times x minus 3 over our LCD of x plus 1 times x minus 3. And you don't need to show that line. Like if you were in my classroom and you were doing an exam or something, and you went from this step right here, you showed me this, and then you were able to get down to this next line, like I'd be okay with that. Like you would just distribute here rather than writing it down. But just for the sake of this video, I might as well just show the steps here. I'm not trying to rush through it or anything. So here's what I did. I just wrote this as 4 minus 2 times x minus 3. It's extremely important on this problem that we identify the next step correctly. Since I'm subtracting off this entire fraction here, I am subtracting off all of this. When I distribute, am I distributing 2 or am I distributing -2? The answer, distributing -2. You want to make sure because you're subtracting off 2 times x minus 3. So it's -2 times x, -2 times -3. If this was an addition problem, and I'm going to erase this, but if this was like plus 2 over x plus 1, and then you do your steps of x minus 3 and everything, you could accidentally get the correct answer and not really think about it because it's addition. Because it's positive 1 times 2, so you'd just be doing 2 times x minus 3. So 2 times x, 2 times -3. But here, since it's subtraction, really easy to miss that step. So we are distributing -2 into the parentheses. So I'm going to do 4 -2 times x, -2 times -3. So that's going to be -2x. -2 times -3 is positive 6 over the denominator of x plus 1 times x minus 3. Let's simplify this down a little bit. So I see just a 4 plus 6 up here. So let's simplify that. So 4 plus 6 is 10. I'm going to write this as negative 2x plus 10 over x plus 1, x minus 3. And you could do one extra step here. So I'm just going to do one more thing. See how this is negative 2 and 10? I could take out the negative 2. So I'm going to, because 2 goes into 2, 2 goes into 10. So I'm going to take out an leading negative there. So I'm going to take out a negative 2. And what I'd be left with then is just x minus 5. Because this is negative 2x plus 10. And if I take out negative 2 from both terms, this just becomes x, negative 2's. And then 10 divided by negative 2 is negative 5. So you get x minus 5. And then you'd have that LCD of x plus 1 times x minus 3. Doesn't help us. Doesn't do anything for us. But I guess the technical answer would be that. Like if you want to get it down to simplifying as much as possible, you'd probably write it like that. Because in some cases, this is what might happen. Like let's pretend that there was an x minus 5 on bottom. Then x minus 5s would drop out. But in this case, it's just x minus 5 and x minus 3. So it doesn't help us at all. So not the biggest deal in the world, but I think you would probably want to just simplify that down. So good problem here. The key to this problem was the fact that we have subtraction. So when you are multiplying by that x minus 3, you want to do negative 2 times x, negative 2 times negative 3. I'll say that again and again and again in my classes, and people will still make mistakes on that step. So maybe just make a note to yourself and highlight that, circle that, just like right here. I got to do negative 2 times x, negative 2 times negative 3. If you do that, I think you'll be okay. So I hope this helps.